Hello students, we are doing the portion on irrational numbers and this is a question related to irrational numbers. It says that prove that root 3 plus root 5 is irrational. Now we solve these types of problems by using the method of contradiction. So we will be solving the sum by the method of contradiction. That means first of all we will be assuming this number root 3 plus root 5 to be a rational number. So let root 3 plus root 5 be a rational number. So we know that any rational number can be expressed in the form of p by q, where p and q belongs to the set of integers I, and q is not equal to 0 because q is the denominator, and of course p and q are co-primes. That means they do not have any common factor between them. It does not mean that p and q are prime numbers. P can be equal to 8, q can be equal to 9. Neither 8 nor 9 is a prime number, but 8 by 9 is a rational number because p and q are co-primes. Rational number in its simplest form, in its lowest form, because p and q are co-primes. That means 8 and 9, the numbers 8 and 9, they do not have any common factor between them. So we form this equation, that is root 3 plus root 5 equal to p by q. Now we are seeing that this is the equal to sign. This side is the left hand side of the equal to sign and this side is the right hand side. So on the left hand side we see that we have two numbers, two square root numbers. One is under root 3 and the other is under root 5. So we are keeping this root 5 to this part, this side, and we are taking root 3 to this right hand side. We could have kept this root 3 on the left hand side and we could have taken root 5 to the right hand side as well. Why are we taking? Because we want to eliminate the roots. Actually, we are not very comfortable with working with roots. So we want to eliminate the roots as far as possible. So we are taking this root 3 to this side and we are keeping root 5 to the left hand side. Now we are squaring both the sides of the equal to sign, that is we are squaring the whole equation. So root 5 whole square gives us a plain 5. Now coming to the right hand side of the equal to sign. It will be p by q minus root 3 whole square. Now what will that be equal to? We remember of an algebraic identity a minus b whole square. A minus b whole square is equal to a square minus 2ab plus b square. So if we have a equal to p by q and b equal to root 3, then p by q minus root 3 whole square, we can expand it in the form of a minus b whole square. So the first term was a square. So it will be p by q whole square, which gives us p square by q square. The middle term is minus 2ab. So it is minus 2 into a, that is p by q, and b, which is 3. So it is 2 into p by q into root 3 plus root 3 whole square. B square is root 3 whole square. Now root 3 whole square will give us a simple 3. So we have 5 equal to p square by q square minus 2 root 3 p by q plus 3. Now we find that only this term contains a root. So we are separating this term. Since it is having a minus sign in front, so we are taking it to the left hand side so that it gets converted to a plus sign. And we are bringing this 5 to this side, the right hand side of the equal to sign. So we have 2 root 3 p by q equal to p square by q square plus 3 minus 5. Since 5 is taken to the right hand side of the equal to sign, its sign gets changed. It was initially a plus sign. Now it has become a minus sign. Next, we see that 3 minus 5 gives us a minus 2. So in the right hand side of the equal to sign, we are having p square by q square minus 2. And in the left hand side, we have 2 root 3 p by q. Now we would like to keep this root 3, only this root 3 in the left hand side. And we bring this 2p by q to the right hand side of the equal to sign. How do we do that? We see that 2p by q is being multiplied with root 3. How are we getting this term 2 root 3p by q? We are getting it by multiplying root 3 with 2p by q. So if we take this 2p by q to the right hand side, then the multiplication sign will get changed to a division sign. So we have root 3 equal to p square by q square minus 2 divided by 2p by q. And how do we perform a division? We change the division sign to a multiplication sign and we convert the fraction, or in this case it is a rational number. So the denominator will come up and the numerator will go down. So we have the number as q by 2p. And for this part, we are taking 2 is nothing but 2 by 1. So if we take the LCM of q square and 1, the LCM will be q square. So in the numerator, we have p square minus 2q square by q square into q by 2p. This is equal to root 3. And over here we see that there is a q in the numerator and q square in the denominator. So one of the q's can get cancelled from this denominator. So the final expression that we have is, this is the final equation, root 3 equal to p square minus 2q square divided by 2pq. This equation, we number it as equation number 1. But the right hand side of the equation 1, that is this part, contains the division of two rational numbers, p square minus q square and 2pq. P square minus 2q square is being divided by 2pq. Why are these two rational numbers? Because p and q, we know that p and q are integers. So on squaring an integer, we get another integer. So p square is an integer. Also q square is another integer, which when multiplied by this integer 2 gives us a product which is again another integer. And we know that integers, when subtracted from one another, will yields an integer as a result. So p square minus 2q square will give us an answer which will be an integer. And we know that integers are rational numbers. So this part is a rational number. Also p, q and 2, all of these are integers. So when multiplied together, the product will be an integer, which is nothing but another rational number. So we are having a rational number in the numerator as well as a rational number in the denominator. That means we will be having a rational number as a quotient as well, because when we divide one rational number by another rational number, we get a rational number as the quotient. So this part is a rational number. The right hand side of the equal to sign is a rational number. Whereas the left hand side is root 3, which is an irrational number. We know that root 3 is an irrational number. So we are having different kinds of numbers on either side of the equal to sign, which is absurd. The left hand side is having an irrational number, and that is being equated to a rational number. An irrational number cannot be equal to a rational number. So this cannot happen. This is totally wrong. This is absurd. So we can say that the assumption that we had made right at the beginning, that root 3 plus root 5 is a rational number, this assumption was wrong. Hence, root 3 plus root 5 is irrational. We prove these types of sums by the method of contradiction. Every time we take the number that has been given to us to be a rational number, and we arrive at a situation which is absurd. And then we say that since this cannot happen, like in this case, so our assumption was wrong. So the number that has been given to us is irrational. This is the method we employ in proving numbers to be irrational. Or if you have a single number, say simple root 3 or root 5, you can actually divide and get the square root of root 3, and you can show that it is irrational. How do you show it? That is, the decimal representation of root 3 will be non-terminating, non-repeating. That way also a number can be proved to be irrational. Thank you.